Hey guys, today we are doing chapter 24 notes. Today we're comparing two sample means. Again, this is extremely similar to comparing two sample proportions. We're just going to be using means instead. So we still have a new formula for standard error. You're going to make sure you write that down. Before, when we were doing degrees of freedom, you did n minus 1. Now the calculator is going to give you your degrees of freedom when you're comparing two of them. If for whatever reason you're not able to do that, n minus 2 is a pretty close estimate. So are we still using t-model? Yes, this entire unit is t-model because this entire unit is sample means. Sample means use the t-model because we do not know the population standard deviation. Again, when we were using p's before, your null was always p1 equals p2. This time we're using means. So your null will always be m1 equals m2. You have to label which group is m1 and which group is m2. And then your alternate is going to be less than, greater than, or not equal to, depending on the situation. So let's go ahead and do an example. It says, is there a difference between resting poult rates in males and females? A researcher collected data from a random sample of U.S. men and women and found that the average resting pulse rate among the 280 men sampled was 72.75 beats per minute, with a standard deviation of 5.4. The 240 women sampled had an average resting pulse rate of 70.63 beats per minute, with a standard deviation of 7.7. Is this sufficient evidence to say there is a difference between resting pulse rates of male and female? So before I do anything, I need to state which group is which. I'm going to put M1 equals men and M2 equals women. Now, just so I don't have to keep flipping back to this page, I'm going to write down a little bit more information. The mean for men was 72.75, and the mean for women is 70.63, standard deviation, and standard deviation for men is 5.4, and we sampled 280. And standard deviation for women, 7.7, we sampled 240. So this is just so I don't have to keep flipping back. All right, so we need to state our hypothesis. So the null, like I said, will always be, no matter what, M1 equals M2, and your alternate... this time I think we were looking to see if there was a difference, so that's not equal to M2. So you have to state it just like this. The conditions are actually on the PowerPoint, so make sure you write down those in context. So make sure you put those. After that, okay, it wants a couple of things. We're going to go ahead and get standard error. Is this giant square root formula. It is your standard deviation of men, which is 5.4, over the population of men that were sampled, 280, plus the same thing for women. And when you put that in the calculator, you should get 0.905. It also wants to know the t-score. That's going to come out of the calculator. P-value. And degrees of freedom. This is also going to come out of the calculator. If we have to estimate it, though, there are, 520? So I would guess somewhere around 19 if we're doing should be 18 minus 2. Let's put it in the calculator real quick. So I'm going stat test, this time 4. This is a 2-sample t-test. Make sure you're picking t, and there are 2 samples. This time it did not give us data, it just gave us the stats, so I'm using stats. My mean for my first group was 72.75, standard deviation was 5.4, and number surveyed was 280. For women it was 70.63. Standard deviation 7.7 and 240 were sampled, and I think that they are not equal. It was not pooled, so we're going to calculate. So this gives you the rest of your information. I'll scoot this over. My t-score is 3.577. My p-value, be careful of that -4. It cannot be greater than 1. This is not possible, so don't put 3.8. It is 0.00038. And my degrees of freedom's right here, 419, which is fine. Okay, so make sure you write all those down. So my conclusion would be, based on this data, we reject the null hypothesis because our p-value of 0.00038 is less than 0.05. Therefore, we can say there is a difference between resting heart rates of men and women. All right, so that is your p-value one. If I wanted to do the exact same thing with a confidence interval, this one wants the 95. So I want confidence interval. This time I'm going to do stat test down to 0. 0 says 2 sample t interval. Remember, interval gets you the confidence interval. Test gets you the p-value. Still using stats. It was really kind and copied all of our information over for us, but I want a 95% confidence level. And so again, gives you all this information. This time all I need is the confidence interval though, which is 0.955 to 3.28. And this is already written on your PowerPoint. So if you'll look real quick, it says, based on the sample, we are 95% confident that the mean resting pulse rate for U.S. men is between, here's where your confidence interval comes from, 0.955 and 3.28. These are positive numbers, so you would say more than the mean resting rate for women, okay? So because the men are more, that means there is a difference. They are not about the same. If 0 was in this confidence interval, that means that there is a chance that there is no difference, then that's when we would retain the null. But because men are clearly have a higher resting heart rate, we would say we are going to reject our null, and this is why, because the mean we're 95. Excuse me, I'm so sorry. We're 95% confident that the mean is 0.95 to 3.28 more for men. Okay, so it's a little bit different than when you're comparing one mean versus two means, just like one proportion versus two proportion. It's not just necessarily if it falls in that interval. For this one, it's comparing the difference between each group. All right, I believe that is all for this one. Shh, hold on, baby. So, again, like I said, this unit is so similar to proportions. They have very, very minuscule differences. Here, the only difference is we used M instead of P. Your standard error formula was a teeny bit different. But a lot of this is just doing the same thing you did last unit again. So hopefully you guys are doing okay. If you have any questions, please feel free to email me.